Hello. In previous lessons, we've talked about evaluating functions based off of a certain amount of interest per year typically. And in this example, we're going to be talking about taking our interest, specifically yearly interest, and breaking it up over time into smaller increments like months. So let's take a look at this example. In this example, we have the number of users on a website is 9,200 and is growing exponentially at a rate of 49% per year. We have two things we want to do. We want to write a function to represent the number of users on the website after m months. So instead of years, we want to transform it into months, where the monthly rate of change can be found from a constant in the function. We want to round that to 4 decimal places. So we're looking for this number here in terms of month instead of years. Also, we want to determine the percent rate of change per month to the nearest hundredth of a percent. So we want to, after we get that number, we want to figure out what the monthly rate is. So we start by looking at this problem from a yearly perspective. Now, we know that in an exponential growth problem, we have our starting amount, and we have 1 plus our yearly rate raised to the t power, where t is in years. But if I want to convert that to months, and of course, if you add the 1 plus 0.49, you get 1.49. If I want to convert that to months, I want to know, what do I get when I plug in a month? So think about 1 divided by 12. If I plug in 4 years, okay, well, that's the same as doing 48 months, because 12 times 48 is 12 times 4 is 48. So if you look at, let's kind of think about a calculator here for a minute. If I have 9,200 parentheses 1.49 to the 4th power, right? You're going to get 45,345.36. Now, if I convert that 9,200 parentheses 1.49, and I raise that to the 1 divided by 12, and let me put that in parentheses so it stays up there, times 48. Because we know that 48 divided by 12 is equal to 4. So these are equivalent, right? And that's why you get the same number. So what I want to do is I want to look at this 1.49 to the 112 power. I want to see what happens when I convert this number and get rid of this weird fraction up here, 1.49 to the 112. That's kind of awkward to write and input into a calculator. So we want to figure out what that is. So we're going to focus just on that part, 1.49 raised to the 1 divided by 12. And you get a small number, 1.033789679192. All right, so let's look at that number, 1.033789679192. I can replace this 1.49 to the 112 power with that number. So all of that will become 1.033789679192. So the function is going to look like this: 9,200 parentheses 1.033789679192 raised to the m power. Well, I don't want to have this many decimals, so I'm going to round that to 4 decimal places. So I'm going to write 9,200 1.033, and since the number after the 7 is an 8, I'm going to bump that up to an 8 to the m power. So that's actually equivalent to 9,200 1.49 to the t power, where m is in months and t is in years. And I want to just kind of verify that with a calculator again. So if I go back and let's say I plug in 4 there, and I do 1.49 to the 1 divided by 12, and I rewrite this 9,200 parentheses 1.033, I'll just say 8, I'll round that to 8. and I'll put, instead of 4, 48. For the most part, now I did round, they're pretty equivalent, okay? They're off by a little bit because of that, that rounding, but if I go out a little bit more, you effectively have the same number, right? 45,345.36, 45,305.36. And maybe they're off by a little bit at the end because even when you round exponents at the end, this is still rounding it because there's only so many decimal places that Desmos is going to show. Those are the same thing. So getting it in equivalent rates and trying to figure out the base of the exponential function when it's in months is as simple as taking your yearly base, 1.49, and raising it to the 1/12th power, 1/12. And I can also, I can take a year and divide it into days. So I could do 1/365, or I could do it in, quarters, 1/4. So it just depends on the question, but this is a monthly rate. So we want to do 1 divided by 12. So to finish our question, and these are the same thing. The question said, what is going to be the monthly rate of change rounded to 4 decimal places? So if I look at the number that I have calculated, 1.03378, I want to bump that 7 up to an 8. And that's going to be my number in the base. So in here, I would write 1.0338. 1.0338. So now let's talk about the percent rate of change per month. So once I have that number, I can figure out what the percent. Remember that in an exponential growth function, it's still 1 plus the rate. So if I look at this 1.0338 and I subtract the 1 from that, my rate is going to be, well, it's going to be 0.0338. Now, if we want this in a percent, I'll have to convert that to a percent by multiplying by 100. So that's going to be 3.38%. 3.38%. So I'm going to write 3.38 in that box there. So 1.0338 to the m power, where m is in month, and then the percent would be 3.38% right from there.